Okay, this is geometry. It's going to be notes for 4.3 day 2, but we're going to go over 4.3 day 1 corrections. And I'm doing it in its entirety, and there are going to be some that I hold out to grade. And reason why, because these are things that we've been doing since last Monday, Tuesday, and I want to see do you gets it or not, and those are the ones I'm actually looking at, and I'm going to give you points out of 3 on, and that'll be your points on this assignment. So on number 1, I've got triangle JIH congruent to triangle KLM, angle side angle congruence. 3 is triangle RQS is congruent to triangle TUV, angle side angle congruence. I get to choose one of these 2 or 4 to grade. That's my choice. Okay, and then as we're going through here, we got 5. Ooh, it's a proof. Okay, now remember, nothing that I have on proofs hasn't been given to you in class as an example, or on a previous assignment, or in your notes as an example. I mean, proofs are a combination of steps that we continually go over to give you an example of where and when I use them. Okay, and if you got questions, ask them. If you got confusions, clear them up. Okay. Now, as we're doing this, I'm looking at my given, and every time I go about doing a proof, I look at my given and go, okay, segment BD is perpendicular segment AC. So that I've referred to as last week as the perpendicular 2-step. Because when I give you perpendicular segments or lines, I am telling you that I'm going to give you right angles, and all right angles are congruent. That's the perpendicular 2 steps. There's 2 steps with that. And so I'm going to give you an example of what that is. I said ADB because these are perpendicular. ADB and CDB are right angles. Now those 2 right angles are congruent because we learned in chapter 2 that all right angles are congruent. So I know that although they are right angles, they are congruent to each other. Okay, that's the first thing I'm getting out of the way, and I've talked about that as the perpendicular 2-step. You see perpendicular lines, you got 2 steps that's saying the angles are congruent. Now, the next thing, and I'm going to hit that with red, that was my perpendicular 2-step. That's what those 2 are. And I got BD, segment BD bisects angle ABC. Okay, segment BD bisects ABD. So ABC. This is an angle bisector. This is cutting that one angle into 2 equal or congruent angles. So once I know that ABD, I got ABD and CBD are congruent because of definition of angle bisector. Okay, those are straight up. They are very straightforward. It's all about vocabulary. So now I'm looking at this, and I hope you started noticing that as I was talking about these, I was looking at, I'm going to mark these, that's what we just did. I was looking at this segment, BD. It's in both triangles. Did you notice that? So because it's congruent to itself, we get to use the term of reflexive property. So I've got my angles, or my reflexive property, and then I can talk about angle side angle. So that's what I've got going here as I get this done. None of those reasons or steps are new. They're all review from last week, and if you just reread your notes, they would have kind of hopefully jarred your memory on how to use them. Okay, moving on to the next ones. There we go. Notice that as I read my givens, I go right to my diagram to mark it up and to learn more that my diagram is going to give me versus the given statements. Okay. In this one, I know that JLK and PLM are congruent because I have that bow tie configuration. And when I have that bow tie look, I'm talking about vertical angles. So that's going to be something I'm going to do, but I'm going to check my other stuff. I've got K and M, they're congruent. I've got this marking and that marking. Those are congruent. And you know, I got angle side angle here. Do you see it? I have to talk about the vertical angle pair that I've got after my given, and then I've got myself, I got my given, I got my vertical angles, and now because I've got a angle, a side, and an angle. Now, right now I got a couple people that want to go, oh, boom, that's like angle, angle, side. No, slow down. Look at the configuration. When I'm comparing angle, side, angle, and angle, angle, side, it's significant to pay attention that when I'm working with angle, side, angle, the two congruent angles are connected to the congruent side. Okay, this is two congruent angles connected to the congruent side. So this is angle side angle. The other is angle angle side. One of the angles that's congruent is not connected to the congruent side. All right. So in this case, it's the two angles are connected to the congruent side. That's why I can say angle side angle. Now, how's a three-stepper? It's pretty friendly. Okay, pretty okay. But if you made some mistakes when you did yours, read what you wrote, read what you should have wrote, and ask yourself, could you avoid that mistake in the future? Do you know better now, or do you have to ask a question to clarify what's going on? Okay, because it is about you asking questions and clarifying. That's how learning takes place. Okay, you keep repetitively doing the same thing, trying to make sure you have the goal of getting it right. Okay, if you get it right, fantastic. It doesn't happen by mistake. Okay, it happens because we keep focusing on that as our goal, and we keep repeating the same stuff, the same ideas, and hopefully that you're picking up on them. If you're not, let's start talking about it. Raise your hand. But in 7, remember when I said if I give you parallel lines that like 95% of the time it's alternate interior angles? This is one of the times it's not alternate interiors. So we're looking at corresponding angles. Thank you, sir. Okay, so we're looking at corresponding angles, and when people are looking at this, I got this parallel line, that parallel line, here's my transversal, and check them out. Corresponding angles are those two angles that I just marked. Okay, they're not alternate interiors. I've got parallel lines, and all of a sudden, your first example actually is the second example. I think we've done this before, that we have parallel lines, and it's not alternate interiors. It's just the corresponding. Okay, so I've got corresponding angles because of the parallel lines. And then I've got congruent sides and congruent angles. So I'm leaning on angle side angle for my final triangle, my triangle theorem or postulate that I use to prove these two triangles congruent. Okay, so that's what I'm leaning on. So the first thing I'm going to do is talk about given. Then I'm going to go for CAP, corresponding angles postulate. Okay, got my given. Now I'm going to go for corresponding angles. Well, I've got my corresponding angles. I got my given. And now I can finish it off, and hopefully you were able to finish off angle side angle. How did it go for you? Check yours. Make sure it's going. If it's not going, if you've made a mistake, make the correction. Physically rewrite it. Reread it. Check it out. That's why I'm doing it this way, like it's in notes. Okay? Because you had an opportunity to try on your own, and now we are like running the tape or video and saying, hey, okay, did you do it right? Or do we need to fix some stuff? Okay, so this is our opportunity to look back and go, all right, what can I do differently to get them right? Are there questions about 6 or 7 at all? Okay, let's look at 8. Again, I look at my given. I mark up my diagram based on my given. Okay, hey, I got the perpendicular two-step. Bloom's talked about this one already today. I got two segments or lines perpendicular. They're going to make right angles. All right angles are congruent. That's the two-step. Okay, then I'm looking at bow tie. I got bow tie going on here. This is vertical angle theorem. Oh, what the heck? T is the midpoint of segment PR. What's midpoint mean? Ideas? What's midpoint mean? Any ideas about midpoint? We did it for chapter 1. If I tell you something's a midpoint, what is it? Mr. Levine, what do you have, sir? Both sides of the segment are equivalent. Awesome. All right. Now, the only change I would make is congruent. Okay. So in your mind, you're seeing that. Fantastic recall. And remember, that's all about us recalling our properties. So now we got midpoint. They're both congruent. Okay. So now I've got my given down. Got to get it all down. Boy, it's a lot of given. But I got the perpendicular two-step. Let's get that out of the way. I got my perpendicular two-step going on. And because they're right angles, all right angles are congruent. I have to talk about them being right angles before I can say they're congruent right angles. Okay, so I've got that done. Let me double check that. So because of that two-step, I got this. Now, I got vertical angles and I've got midpoint. I'm going to do the midpoint next, I think. So I've got PT and RT because definition of midpoint, and I dropped the OI. I got midpoint. And now I'm looking at the idea of, all right, I got midpoint in there. And remember, T was the midpoint of PR. It was not the midpoint of QS. So I got to make sure I'm working with the right segment when I do this. And then I got to look at the fact that it's a bow tie configuration. So this angle and this angle are congruent because it's in bow tie. Okay. And I got that going on, and I finish with my angle side. Notice the difference. I got two angles and a side in this one, but both angles are not connected to the congruent side. So that's why I get to say angle side versus side angle. Okay. We're doing okay? Now, 9. Check out the given. I got an angle, and then I got parallel. Okay. And when I look at the diagram, I'm checking this. I'm like, hey, you know, with these parallel lines, that transversal, these are alternate interior angles. And also, this is reflexive as I'm going through it. So I'm thinking, okay, I got my given, I've got alternate interior angles, I have reflexive. And then I have angle, side, angle for my congruent triangles to be congruent. But you notice how I didn't even lift a pencil? I just went in, I looked at what my given was, I looked at what I had in my diagram, and then I have my rough draft of my proof in my head. And then I go ahead and go, okay, I got my given. Okay, that gives me this angle, so I'm going to mark that angle. I'm going to put it in red because that's what they gave me. And that one. They got parallel lines. Now parallel lines, I've got alternate interior angles for my parallel lines. And now I'm looking at, well, gosh, forgot alternate interior. I just got to do the reflexive, and then I'm done with my proof, angle, side angle. Are we doing okay? Is it making sense? Now, folks, if there's a question on what I did or how I did it, now's the time to ask it, because I always get a kick if somebody goes, oh, I meant to ask that before the test. I went, dude, it's right now. This is before the test. Let's ask it. Okay? This is the best time to do it, too. Now, as we're going through today, please keep in mind, I have not used one thing different than what I did on previous notes all last week. So if you even had your notes out, the same given or the same situation in a diagram, I use the same reasons and statements to make it happen. Okay, I did not like create something new from something. Okay, it's very, very repetitive what we've been doing just to make sure you're getting exposure to this stuff. So let's look at 10, or I think this one's the other 9. Look at that, it is another 9. I have angle 1 and angle 2 are congruent. Okay, and then I have DH. DH, and I'm looking at DH, hey, you know something, that's reflexive, but it's also an angle bisector. And an angle bisector is talking about it's bisecting BDF, so BDH and FDH are congruent because DH is an angle bisector. It's also reflexive. Not because that DH is an angle bisector, it's just reflexive because it's a segment or a side in both triangles we're working with. So I'm looking at my given, reflexive, definition of angle bisector, angle, side angle to finish this out. And the angles I'm talking about, this angle and this angle because of definition angle bisector, this angle and this angle because they're given, and then this segment because it's reflexive. So those are my steps that I'm working on this. So now I've got that, and I've got those. And remember, this was part of our assignment. So it's something that we were ready to write on Friday. And I'm just stepping through again to make sure you understand what we were thinking about to write them today. I'm just correcting what we did. Now, the most popular question today has been, can I flip-flop these steps? These two steps could have flip-flopped, no problem. Okay, perfectly fine to flip-flop them. All right, if you decide, because they're like socks and pants. I put my pants on, put my socks on, or put my socks on, put my pants on, I still got socks and pants on. They both work, okay? In 10, again, every time, I mean, you can write what you're given, but I just look at the given and I look at the diagram. I check to make sure the things in the diagram have been marked from the given. And they have been. I got an angle and I got a side. And because of bow tie, I got one more angle. Okay, because of bow tie, I have one more angle, so I got vertical angle theorem. Okay, so now I've got my given vertical angle theorem, and I have no need to do anything else because I have the two triangles congruent because of angle side angle. Okay, no need to do anything else. So I got my given, I got my vertical angles, and I'm not sure where the 2 went, but that should be 2. And I got my angle side angle, and I'm done, I hope. But here's the thing, it's only done, it's only awesome if you gets it. If you're not getting it, it's stinky. So make sure you're raising your paw up. We're talking about it. We're discussing the things you're not getting. You're discussing the things, how I know what I'm doing, but I'm trying to do it every time. You look at the given, you look at your picture, you mark up what you got, you look at what you can get from the picture, and you go get after writing that proof. Now, problem 11. This should be straight up golden. And I'm going to not tell you the answer on that. I'm going to actually correct it this way because we should know now. We should. We were pretty good on stuff like it last week. We're going to see what's up. Okay. In 12, in 13, those are straight up. Order matters. We started doing that last Monday. So 7 days ago, that's where we were doing order matters. In 14, in problem 14, I'm looking at the perimeter of a rectangle is 2 times length plus width. In the problem, they say the length of the rectangle is 15 times its width. I don't care if it's a vegetable garden. It could be, you know, a room, my bedroom. It could be downstairs, our driveway, whatever. I'm going to fence in my driveway. I'm not sure why I would, but it could be any rectangular shape. I just need you to know that whatever the width is, we're going to multiply that width by 15. So when that happens, I represent my width by x and my length by 15x, and I've got my length and width. So that's where I got 15x plus x. That's 16x times 2, which is 32x. I further found that 160 is my perimeter. So 160 is equal to 32x, and I divide by 32 and I find 5. That is still not my answer. Oh, people are like, no way, really? I know my x value is 5. Now I multiply my x in there, and I know my width is 5, and my length is now 75. And that is not my answer either, although my width and length are 5 and 75. My answer is the area that it takes up. What area am I fencing in? So I'm going to multiply 5 times 75, which is 375 feet squared. That is my area, and that is my final answer. I had a bunch of spots all the way along that you could have stopped because each one was equal. Pay attention to what you're asked to find each time because that's really what's going on. 15, I give you the formula, the average of the x's, the average of the y's. I'm looking for the answer on that when we actually go through this. It's a review problem from chapter 1 and 2. Okay, so if you're done with all that, please make sure your moniker's right on top of it, your John Henry, your John Hancock, however that is, and make sure you pass that stinker forward. And then let's get to chapter 4, page 8 notes to do our next thing. Now, we've done this word bank thing before, except before we've done the word bank as Bloom just gave you exactly the stuff on the left, the stuff on the right, and exactly what we're working with. Thanks, Remy. Okay. Now I'm giving you everything mixed together, and I gave you more reasons than you need. So now I'm going to talk through the 20-second ticker and see what we know. And then from that, you're going to write the proof. So here's the 20-second ticker. I got a given. I've got angle N and angle P. They're kind of marked. I've got MO, and QO. They're kind of marked. But, oh, wait a minute. I got this triangle and this triangle congruent is what I'm supposed to write. Hey, look, it's a bow tie. Do you see bow tie? So I've got vertical angles. If I do vertical angles, which one of the triangle congruents would have an angle and a side like that? Wow, an angle way off on its own and an angle connected to the side that's congruent, and you guys are ready to write this sucker. It's 3 steps. Go. We're doing problem 20, I think it is. 19, I lied. 19. Remember, if you're watching this, you should be trying to write it for your first time, because this is just the 3-stepper. You got yourself a given, you got yourself vertical angles, and you got a triangle congruence statement. And you only have 4 choices from that: side, 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 angle, angle, and angle, angle, side. So let's get on this thing. I've got my given. I'm all good with that. And then I talked about vertical angles, so we got vertical angles going on with angle MON and congruent to angle QOP. If you wrote angle NOM and congruent to angle POQ, you'd be fine. That order is a flip-flopper. That's fine. But now, my last thing, are you okay with angle, angle, side? Okay, some people are happy about it. Some people are pumping their fists. Some people are doing their little end zone dance party. Others are just frustrated to all get out because they're like, I was close. Keep working at it. It's going to be okay. Ask questions if we're not sure. Our next one. Look at your given. Look at your diagram. This is how I start every time. Okay. Remember, the goal is to have 3 somethings congruent to 3 somethings, and the somethings are based on side, 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 angle, angle, and angle, angle, side. Okay, they're like my laundry list. Which ones do I need? I'm going to do this one. Well, I do it based on what I'm provided. So let's look at what I can get. So let's look at this. So I've got FJG. FJG is marked. That's awfully kind of them. And HJGJ. Well, you know, and I've got this parallel thing, and maybe what I should do, let's change colors. I'm going to make these red. I'm going to make those red, if I can make those red. It's here someplace. Somebody said it would be red. Well, we're making them red anyways. I'm not sure why it's not there. There it is. There it is. We're going to make those red, maybe. We're making something red. Sorry, guys. We're going to try to get this again. I want this there. I want to go here. I want to go these guys. I'm not sure why nothing's working. Okay, maybe. Maybe because I've got that. Let's go back to pointer. Let's see what I got here. Okay, there it is. Phew. Right there, I couldn't find nothing. Okay, so those are red. Let's talk about blue. My parallel lines is blue. These are going to be congruent because of alternate interiors. And then my last one, JG, is going to be congruent because of reflexive. So, gosh, I got angle, side, angle. That's the one I'm going to use. Do you see how it's there? It's sitting there. I can prove that stuff. Okay, so I'm going to go after it and get it done. Maybe. Now, all that stuff was there in the word bank, but I know it's jumbled in there, and you have to search for it. But that's what I've got. Is it making sense? I didn't decide on which triangle congruence I was going to use until I knew what I could prove based on the given and the stuff in the diagram. Okay. Hey, we're going to do 25 next. Oh, boy, 25 looks really familiar. I bet you A and B are probably congruent because of cap. Go for it. Go for it. And I use B loosely. You got to use the 3-letter name for B because there's like six angle B's there. Give it a try. Remember, some of the ways that a math teacher or a student uses to get better is repetitively doing the same problems that gave them problems. Okay, if you're not good at something, try it again. Okay, and some people, oh, that's ridiculous. Oh yeah? If I hang a can in the corner of a goal and you didn't hit it the first time, do you think you're just going to stop? You're going to adjust your shot and you're going to do it again. Okay, try to hit the can. You know, it's proof that you're hitting that corner of the goal for a slap shot or a wrist shot. Okay, so same idea. I mean, if I don't succeed the first time, I do it again. Same shot, same spot. I just try to better my aim. Same idea here. We're just trying to better our aim with our understanding of what we're supposed to do at each step. Again, start at the given. I got parallel lines. I should be thinking something with angles. In this particular case, my parallel line, just like the one we did earlier, is working with two angles that are congruent. And they are actually corresponding angles. So by cap, corresponding angles postulate, I know that angle EAB and angle DAB or AC, or DBC, excuse me, are congruent. Okay, so that's by cap. That's my parallel lines. The other two things are a side and another angle. Well, geez, I got my given, I got cap, and I'm done because I've got an angle side angle here in this two sets of triangles, and that's the one I can use. How'd you do? Is it making sense? Okay, I got some head bobbles, more head bobbles this time. That's awesome. Okay, keep in mind, I am not doing anything fancy schmancy. I'm still doing the same stuff we've been doing since last week, since we started with notes today, and we're continually doing the same thing. I'm working with those 4 triangle congruence statements. You know, the triangle congruence theorems or postulates. Side, 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 angle, and angle, angle, side. It's one of those 4, and I have to have supportive evidence. If I'm going to use one of them, I've got to have the parts of those ones that I'm using proved in my steps in my proof. So this next one, I got a given. Angle 1 is congruent to angle 2. DH bisects angle BDF. Now that bisects gives me 2 angles that are congruent. It takes a big angle, cuts it in half. Okay, so when I'm reading that bisects, I'm talking about this BDF, and it's being cut by DH to make this angle congruent to this angle. Well, that's kind of cool. So by definition of angle bisector, I've got that angle. Well, do you see that DH is in both those triangles that I'm supposed to prove? If I look at the triangles, I'm supposed to prove BDH and FDH. Well, if I got BDH and FDH, DH is in both of them. So I know that that is, DH is congruent to itself, reflexive. So I've got a reflexive property, and that's this guy right here. So if I use that as reflexive, and I got the angle that was given and the angle I just found because of angle bisector, I got angle side angle to prove the 2 triangles congruent to each other because the 2 angles are attached to the congruent side. So I just got to organize it out and write her down and get that thing going. But you got to keep in mind, I go over it and 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 over it, and then when I'm done with it, I do it again to be better at it. Matter of fact, this page, except for problem 15, you'll be able to practice. You just take a blank piece of paper, cover up all the other stuff, look at the picture, the given, and to prove, and you can rewrite a proof just to practice to see if you gets it. Okay? Some people go, oh, that's being a study buddy, Bloom. Nobody wants to be that. But everybody wants to improve. That's how improvement happens, practicing. Practice something you already know the answer to, and try to do it cold without looking at the solution. Okay, try it on your own. Just kind of bring that piece of paper over the top. Make sure it's one that you can't read through the center. Oh, it's right through. I'll just write on top of it. Okay, don't use your x-ray vision to do it. Okay, but give yourself a chance to practice. Last one, giving yourself a chance to practice. No net. Write it on your own. No net on this one. I'm not going to say anything. See what you know. See what you know. When you're done with this one, look left, look right. Don't rush anybody. Compare your answer with somebody else next to you. Oh, nuts. I got 52 pickup, don't I? No, I'll get it. Thank you. That was a good block you got. You did the maneuver job. Just denied me on that. That was awesome. Okay, 20-second ticker. I got my given going on. Holy cats, I've got 2 sets of parallel lines. That means I'm going to have 2 angles that are congruent because of alternate interior here. So let's check that out. I got this, and that's my congruent angles. I've got this, and them's my congruent angles. Okay. Remember, if I have a pair of parallel lines, I have a pair of angles. If I have 2 pairs, I have 2 pairs of angles. Now I got my angles in there. Hey, check it out. I got reflexive. That's coming right across there. Did you see them all? So I've got angle side angle on this. Excuse me. Now, I got a couple people, I don't know why I wrote reflexive twice. You only need to write reflexive once. Does that make sense? So let's get rid of this one reflexive. I'm just going to do it small. So you guys can just do one reflexive. We'll just write it once. Okay, I just got carried away. Are you